This is a quick example, just to have another one, of intervals of concavity and points of inflection. But again, we're going to start with intervals of increase and decrease because we've got to find the first derivative anyways, so why not show the connection? So, first derivative, we have to use chain rule. So 5/3 x minus 4 to the 2/3, and then derivative of x would be 1, so we don't need it. Okay, so now we would set this equal to 0, and we get x equals 4. That's the only one we have, and so we should plug it in the calculator to verify it. And I already have. There it is there. There's its graph, and you can see at 4, everything is good. So if I hit trace 4, see it's right in the middle. So from here you can see it's increasing and increasing. So when we take our first derivative of something to the left, like negative 100, and we'll take our first derivative of something to the right, like 100, and we plug that in, negative 100 minus 4, it doesn't matter what this is sign-wise because that is a square. So when you see x minus 4 to the 2/3, remember this is really just the cube root of x minus 4 squared. And so we're squaring that. It'll always turn positive. Our function is positive all the time. And so if it's positive, that means it is increasing. So it is increasing from negative infinity to positive infinity all the time. There is no decrease. And so if we don't get a change from increase to decrease or decrease to increase, there's no relative extrema either. And there we go. So how about intervals of concavity? It would be the same thing. So let's rewrite our derivative. And we take our derivative again. So this would become 10/9 x minus 4 to the negative 2/3. So rewriting, we would get 1/3. We would get 10/9, and then that would be the cube root of x minus 4 this way. But these work the same way. You can have a d and e as well. So this would still give us x equals 4. So it doesn't have to be just 0. It can also be a d and e. So we put 4 on there, and then we go back and we look at our graph. So you can see it's concave down here and concave up here. So that will be our point of inflection at 4. So 4, 0. We already know our point of inflection. But again, we want to do a second derivative over here. So negative 100. 100. And then we do exactly the same thing we did up here with increase and decrease. So f prime of 100, this is now not having that situation here where we have a square, so we do actually have to calculate it. But the 10 and the 9 are positive, so this is the only one that is giving us our sign, is our x minus 4. So if I plugged a negative 100 in there, that would be negative 104, which is negative. So we know this is negative and it's concave down. I'll just put the giant concave down like that. And then the other side is positive, so we know it's concave up, because again, the same rule is going to apply here. I'm putting arrows on it. Concave up, positive. I got in parabola mode there. So we know that it is increasing. Concave up, the derivative is increasing. Concave up from 4 to infinity. And concave down from negative infinity to 4. And again, you just have to check the calculator to verify that. And it is. See, there's concave down, concave up. And since we do have a change in concavity, we know that we have a point of inflection at 4, 0. And where I got that from is, again, just plugging in trace 4, and it gives me 0. So again, for all of these answers, we are just looking at the original function, that f of x equals x minus 4 to the 5/3. And the first derivative is telling us if it's increasing or decreasing. And if we get a change in increase to decrease, we know we have a relative extrema. We don't here. And then the second derivative is telling us how our derivative is changing. And so if we have a negative, we know it's concave down, and our function's concave up when it's positive. And if we have a change in concavity, we have a point of inflection. And to find those points, remember, it's where our derivative is equal to 0 or d and e. Same thing up here, derivative is equal to 0 or d and e, second derivative equal to 0 or d and e, and there you have it.